Question 19. So we have a trig substitution, right? This is one of these trig substitutions that doesn't look like a trig substitution, but we have something like a squared minus x squared. So this should make us think a times the sine of theta. All right, so since a squared is 100, let's say let x equal 10 sine of theta. I'm going to worry about this these fives at the end, aka my limits at the end. So we have the square root of 100 minus 10 sine of theta squared. So dx is going to equal 10 cosine, negative 10 cosine of theta. So that's going to give us what? That was an awkward pause. So that's going to give us the square root of 100 minus 100 sine squared of theta times negative 10 cosine theta. Okay, so I can factor 100 out of still in the square root. So I'm going to get 1 minus sine squared of theta times negative 10 cosine theta d theta. So I can use my rules of square roots to write it this way. 1 minus sine squared is cosine squared. So I still have this. I'm going to pull this negative 10 out. Right there, cosine. Did I really say that the derivative of sine was negative cosine? I don't know if you can see the clock behind me, but it is a wee hour of the morning, and those mistakes happen at the wee hour of the morning. I knew something didn't feel right. That's why there was an awkward pause. So this would be 10. So we can, and this would be just cosine. As we simplify, so we're going to get 100 cosine of theta times cosine of theta d theta. So I'm going to write this up here in the essence of horrible board work. 100 times cosine squared of theta d theta. So at this point, it might look like we're a little bit stuck, right? But we still have some trig rules that we can break out, right? So let's turn this cosine of theta. And so if we think back to our trig rules, so we have a trig rule for this thing right here. Where's it at? Where's it at? Where's it at? Over here somewhere. Here, right? So we know that cosine of 2x is equal to 2 cosine squared of x minus 1. So if we use that, if we use this, where's this thing even at? If we use that, cosine of 2x equals 2 cosine squared of x minus 1, then cosine squared of x would equal 1 plus 2 cosine of 2x. So then we can take this integral and rewrite it as 1 plus 2 cosine of 2 theta, right? Because I have thetas instead of x's. D theta times 100. Then I can take this integral in parts. 100 times, well, the integral of 1, because we have a d theta, it's going to be theta. So 2 cosine of 2 theta. So the antiderivative of cosine would be sine. So we're going to get plus 2 sine of 2 theta over 2, right? The antiderivative of, so if I took the cosine of 2 theta, if we said let v equal 2 theta, dv would equal 2 d theta. And so d theta would equal dv over 2, right? So this would be a dv over 2. This would be a cosine of v, right? So that's where that comes from. Right, and then now let's turn everything back into our x's, right? So for theta, what we had x was equal to 10 theta. So this would mean x over 10 is the sine of theta. So thus theta would equal the arc sine of x over 10. So we're going to get 100 times theta was arc sine of x over 10. No, that's right. Arc sine of 10. Yep. Plus 2 sine of 2 arc sine x over 10 over 2. Right, so these 2's cancel. I don't know why I wrote them. We're going to evaluate this from 0 to 5. So for the arc sine, right, so a couple of things we could do here, but I'm just going to actually write this in because I don't feel like explaining what happens with sines and arc sines and that cancellation, but you probably know that they cancel. So we're going to get 100 times the arc sine of 1/2, right? I just plugged in 5 for x, plus sine of 2 arc sine of 1/2 minus 100 arc sine of 0 plus the sine of 2 arc sine 0. Right, so the arc sine of 1/2, right? What value, how many radians give us 1/2? This is going to be pi over 6 plus 2 times pi over 6. So the sine of 2 times pi over 6 would be pi over 3. So the sine of pi over 3 is radical 3 over 2. And then we're going to take away, well, the sine of 0 minus 100 times the sine of 0 is 0. Well, the arc sine of 0. How many radians give me 0? 0. So the arc sine of 0, so the sine of 0 is just going to be 0 again. So we're just going to end up with 100 times those two things. So 100 pi over 6 plus 100 rad 3 over 2. We can simplify this into 50 over 3 pi plus 50 radical 3. That's harder than anything I'd give you on a quiz or test.